What we have here is a 9XA hybrid. The house AC going through the variac, through a full wave rectifier, not drawn, non-filtered, basic 9XA setup that's used for with a high side NPN driven by the optocoupler and a signal generator. So we have the 120 hertz carrier pulses and 5 kilohertz modulation on them. Standard high side NPN, high voltage, 650 volt, fast switching diode. And then this particular transformer here, this guy you see here, 6-to-1 iron core, is connected in an unusual manner. So more on that in a second. But continuing on, this goes to the water fill cell, which is 9 3-inch tubes in series, approximately 100 picofarads, to ground, to the rectifier ground. This transformer is connected one leg, and then it can be made via alligator clips positions to be put in series. So the secondary coil on the transformer can be put in as the VIC choke in the circuit, or it can be left out, and we'll look at both. This is a 6-to-1 iron step up. The high voltage side, which normally takes 120 volts, is connected over here with no connection at the top, and one connection going to this 1 microfarad 2 kilovolt microwave oven capacitor, and the other side of it is not connected, as you can see. So quick look around. This is the variac off of the mains, kilowatt meter variac, current limiter, 250 watt bulb, going straight to, going to the dual. Got 2 in parallel with some heat sinks for higher current work, but we're barely using about 10 watts here. And this is the rectified output, which goes into the 9XA, which is inside this box, and have a current meter also. And we'll be looking at the scope waveform, which looks like this. So this is the 120 hertz unipolar pulse from the regulated output. And this is the production from all 9 cells. It progressively increases. But that's not what we're here to look at. So we're going to let that run. We're going to come back here. Now, remember I mentioned this strange connection. We have there's no electrical connection between the primary and secondary, where we have this capacitor and this wire coming off of it here. And currently, the primary side is not in the circuit either, only the one leg connected. So it's seeing the potential here at the one leg, because both of these alligator clips are shorted together. So first up, move that down, bring this over, and I will show you taking an LED, and we could touch it to the transformer, the casing, and it lights up. There's no current flowing through the transformer, no magnetic field. Touch it to the capacitor, casing, it lights up. Now, what will be more apparent in a minute when I hook in the choke to describe is there is an electrostatic vibration that exists on the surface casing of this capacitor, and you could feel it vibrating on my finger. When I hook this up here, it will be loud enough for you to hear it when I drag my finger across it, and it will have much more brightness on the LED, as well as perhaps the fluorescent bulb, which probably doesn't light now. It's a little, I gotta turn off some lights probably for you to see it, but you should be able to see it when I hook this up. So now we'll put the choke in the circuit. primary here connection, we will make that connection. So now that primary is in series to the wire fuel cell, and you could probably hear the high-pitched 5 kilohertz coming through now that it's pulsing. And we'll do a quick bubble check. We're cooking completely saturated. Now back to the capacitor. Hook up the LED. It's much brighter. Same with the transformer. It's not polarity specific. I can flip over the LED and it continues to light in both places. Now for the fluorescent bulb. You can see, there we go. There's enough to light the fluorescent bulb. Is it brighter when I touch it to the terminal? Yes. Will I touch that terminal with my finger? No. Get rid of some more light here. Just from the casing. So now for the vibration. See if we can zoom in. And pick it up without touching it. And the pitch that it vibrates at is specific to the pulse train. I shall now demonstrate. Going down to about 4 kilohertz. You can hear it a little bit louder. Must be more of a natural resonance for this capacitor cavity. Notice no vibration when I touch the sticker. Any finger. This is a little bit too when does it not do it? If I take the primary back out of the circuit but leave the connected reference, it is still there, a small amount. May not be able to hear it, but I can feel it still. That's not specific to the terminal. But it is when it's connected. So here it's not connected. I've moved it to the other terminal. I can still slightly feel it. But when I do connect the primary, it's no longer there. However, if I move back to the other leg, it's there. Do the LED test both ways. On the right side, on the left side. It's a bit dimmer. Still lit, but dimmer. Dimmer from one side than the other. Again, that's the waveform. 120 hertz, 4 kilohertz. There's a variac. This reads high because of the variac 16, and the milliamp meter pulsing the cell is about 60 milliamps. The voltage across the resonant cavity is a resting 80 volts DC or 160 volts peak. Quite a strange phenomenon. Almost doesn't matter that I'm touching both leads. It doesn't matter. I can still touch both leads and touch the capacitor and it lights. Oh, that's strange. Pretty cool, huh?